Now, let's look at Ethereum, which is a very different beast. If Bitcoin is digital gold, then Ethereum is a decentralized world computer. Ethereum allows developers to write and deploy smart contracts. Smart contracts are simply programs that run on the blockchain. These programs execute automatically, cannot be altered once deployed, are transparent, and are trustless. This means you don't need lawyers, middlemen, or escrow services. The code becomes the law. Ethereum used Turing complete programming language, meaning developers can build very complex applications. This led to the birth of decentralized finance, NFTs, DAOs, Web3 applications, and custom tokens. Ethereum originally used proof of work like Bitcoin, but later transitioned to proof of stake, which reduces energy consumption, increases scalability, and improves efficiency. Now, let's talk about Stellar, which is extremely important, especially for Africa and emerging markets. Stellar is a blockchain platform designed to facilitate cross-border payments and asset transfers. In simple terms, Stellar is optimized for moving money fast, cheaply, and globally. Traditional cross-border payments are slow, expensive, and complex. Sometimes it takes 3 to 7 days with very high fees. Stellar can settle transactions in 3 to 5 seconds with fees that are a fraction of a cent. Stellar uses the Stellar Consensus Protocol, which is extremely fast and energy efficient and secure. Stellar also focuses heavily on financial inclusion. This means helping the unbanked, connecting financial institutions, enabling microtransactions, and enabling stablecoin issuance. Stellar allows tokenization of assets, creation of stablecoins, and seamless remittance corridors. This makes Stellar perfect for remittances, micropayment, cross-border trade, and digital banking infrastructure. For Africa, this is huge because many Africans do not have a bank account. Uh, Many send money across borders and pay high remittance fees. Stellar solves real financial problems, not just speculations. Here we're going to compare between the major blockchain platforms. So now let's compare Bitcoin, Ethereum, and Stellar side by side. Bitcoin focuses on being digital money and store of value. Ethereum focuses on being a decentralized application and smart contract platform. And Stellar focuses on being a global financial raise system. So each blockchain has a different design philosophy. Bitcoin prioritizes security, simplicity, and immutability. Ethereum prioritizes programmability, developer flexibility, and application innovation. Stellar prioritizes speed, low fees, and financial inclusion. Bitcoin uses proof of work, very secure but energy intensive. Ethereum, Ethereum now uses proof of stake, which is more scalable and efficient. Stellar uses Stellar Consensus Protocol, it's ultra fast and lightweight. In real world applications, Bitcoin is ideal for long term value storage, inflation protection, and borderless money. Ethereum is ideal for building decentralized apps, financial platforms, NFTs, and DAOs. Stellar is ideal for remittances, payments, banking infrastructure, and asset tokenization. So instead of thinking which blockchain is better, the better question is which blockchain is better for which problem. And this is very important for developers because as builders, we don't chase hype. We solve real problems using the right tools. And in many real world financial use cases, Stellar is one of the best tools available. Before we move into seeing blockchain in action, let's pause for a moment and recap the most important concepts we've learned so far. If you understand these four ideas, then you understand the core of blockchain technology. The first concept is consensus mechanism. Consensus mechanisms are simply methods used by blockchain networks to agree on what is true. Remember, blockchain has no boss, no central server, and no administrator. So the question becomes, how do thousands of computers agree on the same version of event? That agreement process is called consensus. Without consensus, blockchain cannot exist. Examples include proof of work, proof of stake, and the Stellar Consensus Protocol. Each system solves the same problem. How do we trust strangers on the internet without trusting them personally? The second concept is decentralization. Decentralization means that control is distributed across many participants rather than being held by one central authority. This removes single point of failure, excessive power concentration, systematic corruption risks. So instead of trusting institutions, we trust cryptography, algorithm, and network rules. The third concept is transparency. Transparency means every transaction is openly verifiable on a public record. Anyone can see transactions, track funds, and audit the system. This increases accountability, trust, and security. The fourth and final concept is immutability. Immutability means that once data is written to the blockchain, it cannot be changed or erased. No deleting, no editing, no rewriting history. If a mistake happens, you don't erase the past. You add a new transaction to correct it. This creates permanent records, tamper-proof data, and trust without authority. If you remember these four words, consensus, decentralization, transparency, and immutability, you already understand the foundation of blockchain. Now, let's move from theory to reality. We're going to walk through what actually happens when someone sends cryptocurrency to another person. This is where everything starts to click. Let's use a simple example. Alice sends one Bitcoin to Bob. Sounds simple, but behind the scene, a lot is happening. Step one, Alice creates a transaction using a wallet. This transaction contains Bob's wallet address, the amount being sent, a digital signature proving Alice owns the funds. That digital signature is created using cryptography, and it proves only Alice could have created this transaction. Step 2. This transaction is broadcast to the network. That means thousands of nodes across the world instantly receive it. At this point, the transaction is unconfirmed. Step 3. Nodes now begin to verify the transaction. They check, does Alice actually have one Bitcoin? Is the digital signature valid, and is she trying to double spend? If everything checks out, the transaction is considered valid. Step 4. Miners or validators group many transactions together and place them into a block. This block now waits to be added to the blockchain. Step 5. Through the consensus mechanism, the network agrees. Yes, this block is valid. Once agreement is reached, the block is added permanently to the blockchain. Step 6. Bob receives confirmation that the Bitcoin is now his. The entire process happens globally. It takes minutes or seconds. It requires no banks, no clearing houses, and no government permission. This is borderless money in action. A person in Nigeria can send money to someone in Brazil in seconds without asking anyone for permission. That is a massive shift in how financial systems work. Now imagine not just money, but contracts, property, identities, healthcare data, votes, and financial assets moving this way. That's why blockchain is revolutionary.